Okay, so you're welcome. One of the other things that we're going to do in lecture 2 is to look at measures of central tendency and dispersion. Okay, so it seems we're moving a bit faster. Okay, because yeah, from chapter 2, I think the previous slide is the end of chapter 2 where we did the data presentation. Okay, so we now move to measures of central tendency, location, and dispersion. And this will only be for ungrouped data. Okay, so this will only be for ungrouped data. Okay, so we need to know the definition of the mean, the median, and the mode, as well as the variance, range, standard deviation, how to construct box and whisker plots, as well as computing coefficient of variation. Okay, so we will do the z-scores afterwards in probability. So from here, we're just going to end up to coefficient of variation. So the measures of central tendency are the mean, the median, the mode, geometric mean, and mid-range. Okay, so these are measures that we use to see how the data is centered. Okay, if you're looking at some class marks, maybe you just want to see the average score. Okay, the average is as well known as the mean. Okay, so sometimes you just want to see the average score. Okay, or you want to see what was the most frequent mark. All right, so then you're trying to use those measures to see how the data is centered. We also have measures of locations. These are used to measure how the data is positioned. We use the weighted mean here, percentiles and quartiles. Okay. And for variation, we want to see how the values that we have vary from each other. So we use the range, the interquartile range, the variance, standard deviation, and coefficient of variation. Okay, so that just tells us what we have just discussed. Okay. Okay, so now we try and define. The mean is just the average, which is obtained by summing. Okay, so the mean is given by x bar. So x and that line on top there of x is known as a bar. So we call it x bar. Okay, so we have the sample mean, which is given by x bar, and the population mean. This symbol that you see there is a Greek letter and it is pronounced as mu. Mu. Okay, so that is mu. So the average is just obtained, or the mean, by summing all the values that you have and divide by the total number of the data set. N, small n just tells you that it is a sample size. And the capital N here shows you that's the population size. So here you're dealing with the population mean, and it is denoted by mu. Okay. The median is just the value that is in the middle of the data set. Okay. So here we have 1, 2, 3, 4, and you have 4 there. Then the value that is on the middle there is the median. And the mode is given by the most frequent value in the data set. So there you have those that are 3. So that is our mode. And for the weighted mean, we are still finding the average, but you have to multiply them with the weights. Okay, so you multiply every value in the data set by its weight and divide by the sum of the weights. So you actually see how this works out. So even for the weighted mean, we have the sample weighted mean and the population weighted mean. So wherever you see X bar, just know that you're talking about sample mean. And where you see mu, you're talking about the population mean. So this just illustrates the values that you would have, x1, x2 up to xn. Okay, so that means just the last value. Okay, and you divide by n. And so similar to the population mean. Okay, so the mean, also known as the arithmetic average, is the most common measure of central tendency. Okay, so the sum is given by that. Okay, so given examples, you have 1, 2, 3, 4, 5. What is the mean? Just add all the values and divide by the number of the values that you have, which is 5. So your mean there is 3. And on the other case, you get 4 as your mean. The other measure of central tendency is the median. So it's just the value on the middle there. You have a 3 and you also have the 3. So it's not affected by extreme values. Okay. If n is odd, then you have one number in the middle. Okay, but if n is even, then you have to take the median, you have to take the average of the two middle numbers. Okay, so the other measure of central tendency is the mode, the value that occurs most often, not affected by extreme values as well, used for both numerical and categorical data. Okay, so we may have a case where we have no mode or we have several modes. Okay. So we have an example where we are computing the weighted mean. So sometimes the frequency is very important. Say you want to see the average of how much each salesperson sells, okay, each day, but then you want to see how much or the number of customers that they attend to in a day. Okay, so in that case you would want to see the frequency and maybe the number, the frequency and whatever is whatever you want to weight at that moment. Okay, so you want to see maybe how many salesperson, how many people a salesperson attends to. Okay, so that is the weight. Okay, so the average is not just computed from the frequencies, you also find the weight. Okay, so in this example I given sample of 26 repair projects. So you want to see the number of days taken to complete and the frequency. Okay, so we've been given there the frequencies and the number of days. So to complete the weighted mean, the weighted mean days, we have to use the frequency as well and the number of days taken. So when we do that, we're going to find the weighted average or the weighted mean to be 6.31 days. Okay. Now, there is just a scenario of 5 houses. Just take note of the house prices. We have 2,000. We have 500. Okay, so now I can see both kwacha and dollars. Okay, so we'll just use the numbers 2,000, 500, 300, 100, and 100. Okay, so those are the house prices. So what is the mean? We have 5 of them, so we're going to add the prices and divide by 5. So the mean price is actually $600,000. What is the median? The one that is on the middle. So remember, for the median, the data has to be sorted. It has to be ranked from the smallest to the largest. That's when you pick the one on the middle. So the sorting is very, very important. So when you sort from the smallest to the highest, from the cheapest to the most expensive, you find that $300,000 is the one on the middle, and the most frequent is $100,000. So yeah, which measure is the best? Okay, so the mean is generally used, most used, unless you have extreme values. The median as well, though it's not, and it's good that it's not sensitive to extreme values. Okay, so it just depends up to you what you want to use, either the mean, the median, or the mode. Okay, we now move to shape of a distribution. Given the mean, given any data set, you'd want to know how the distribution is shaped. Okay, so we now talk about skewness. If you have a data set, say on a bar graph, and you have a longer tail on the left, then all the smaller values are on the left, then you say that your data set is left skewed. But if you see that it is evenly distributed, the size on the left is equal to the size on the right, then it is symmetric. And if you see that there are a lot of big values on the right, okay, and very few values on the left, then the tail will extend to the right and your data set will be right skewed. In terms of the mean, actually, left skewed occurs when the mean is less than the median and the mode. Okay, and right skewed occurs when the mode is less than the median and the median is less than the mean. Okay, so to measure location, we use percentiles and quartiles. Quartiles, we just have, okay, we have 4. No, we have 3. Okay, so we have the 25th, we have the 50th percentile, and the 75th. We also have the 100th percentile, but we don't usually use it. Yeah. So we have the 25th, the 50th, and 75th. So the 25th percentile is also known as the first quartile. The second quartile, which is the 50th percentile, is also known as the median, because actually that is the value on the middle of the data set, and we're talking about 50%. Okay. And the 75th percentile is also known as the third quartile. So any percentile can be calculated, but we know that a percentile will range from 0 to 100. So the ith percentile is just given, the position. ith position is just given by that formula, the percentile over 100 multiplied by n plus 1. Example is given and you can follow it up. So the quartiles are just, we know a quarter is just 1/4. So you have 4 equal parts. Okay. So for ungrouped data, if you wanted to find the first quartile, we know that is the 25th percentile. So you say 25/100, and our n is what? N is 9 plus 1. Do that and you're going to find that it is the 2.5th position. So we're going to say halfway between the second and third value, and that is the 12.5. So that is our first quartile. So the quartiles can be used to construct a box and whisker plot. Okay, so this just shows us a data summary. Okay, and we use the minimum value, the first quartile, the median, the third quartile, and the maximum value. These are known as 5 number summaries. Okay, so the minimum there and the maximum will just represent the endpoints. Then we put a box between the first and third, and on the median we put a line as well, as you can see from there. So from the box and whisker plot, we can as well see the distribution of a data set. So if you see that the median is closer to you have a bigger box on the left, then it's left skewed. And if you have a bigger box on the right, then it's right skewed. Okay, then the one that is symmetric will be evenly distributed like that. So that is an example. From that data set, we see the mean is 0. The first quartile is 2. The median is 3, and the third quartile is 5, maximum is 25. So you can see it is drawn to some scale. Of course, it's not exact, but it is drawn to some scale. You can see there's a larger length there between 5 and 27. Okay, so there it just shows we have the bigger box on the right and the longer line on the right as well. So that is right skewed. Okay, so the next thing that we move to now is the measure of variation, and this we are still talking about ungrouped data. Okay, so we are still talking about ungrouped data. So measures of variation give information on the spread or variability of the data values. Okay, so you can see we have the same center but different variations. There's some that are more, you have the high values there, and some you just have, okay, maybe you can just see from this graph. So you can have same mean, you can have the same mean, you can have the same mode, okay? But how does the data set vary? Okay. So we can use the range, which is just the maximum minus the minimum. I think we have seen this when we're constructing frequency distribution tables. Okay, so we have some disadvantages there. It ignores the way data has been distributed. Okay, so you can see there you have this data set there, 1 each, and there you have 12, but then the range still is the same. it is sensitive to outliers. Okay, if you have a big number at the end, then you find that your range is 119. But there, when you just have a smaller number that is close to these values, you just have a range of 4. Okay, so from the range, we have the interquartile range, which is just given by the third quartile minus the third minus first quartile. Okay, so I'm sure you can follow through that example here, and you see how the interquartile range was calculated. Okay, so the most interesting part now, the variance. Okay, so the variance and standard deviation, you'll be dealing with these starting from now up to the end of the course. So you really need to get it right from the beginning. So we have the sample variance and the population variance. Variance is given by S squared. Okay, so that is the sum of each value in the data set minus the mean squared over n minus 1. Okay, so you get that difference, you square, get the next value, the difference, you square. After you are done, add all the differences and divide by n minus 1. Okay, and the population variance is given similarly, except you're going to subtract the population mean and you divide by n and not n minus 1. So the standard deviation is just given by the square root of the variance. Standard deviation is the most used measure of variation, and it shows variation about the mean. It has the same units as the original data. Okay, so we have an example there. We have that data set. The mean is 16, n is 8. So how do we get the standard deviation? So remember, it's the square root of each value minus the mean. Okay, so you get those differences minus the mean squared divided by n minus 1. And you find 4.2246 as our answer. Okay, so let's just see what we are talking about when we're talking about standard deviations. You see these values in dataset A, they are spaced. Okay, so the standard deviation there is 3.3. But in dataset B, the values are closer to each other. So the standard deviation is actually 0.9. Okay, and in dataset C, we can see that there's a big gap between the dataset, and the standard deviation is 4.5. One thing to take note here is that the mean of these datasets are all the same, but we can see the difference in variations. Okay, so we now move to the coefficient of variation. This measures relative variation, and we can find the coefficient of variation for the sample and population as well. So for the sample, it is given by the standard deviation over the mean multiplied by 100%. So the value should be a percentage. And for the population, we see the population standard deviation. So the population standard deviation, that symbol is known as sigma. It's a Greek alphabet letter as well. So that is sigma over mu multiplied by 100%. So we're given an example. The average price last year was 50 kwacha and of the stock A, and the standard deviation is 5. We need to find the coefficient of variation. So we just get our 5 divided by 50 multiplied by 100, and we get 10%. And for the other stock, we get 5%. Okay, so this one shows relative variation. Both stocks have the same standard deviation, but stock B is less variable relative to its price. Okay. All right, so we end here with ungrouped data. The next time we meet, we're going to do the measures of central tendency, location, and dispersion for grouped data. Okay, so please let us go through this and let us revise. I'll send the tutorial questions for this week. Thank you very much.